Now two balls of unequal masses. So first in lab frame, lab frame means ground. Laboratory frame means in the ground, that one. They're moving in opposite to each other. So at one time is saying heavier particle. Something we're discussing about the collision of particles here. So let this be heavier particle. Let me take M1 is heavier particle. It is moving with a V1 and there's a lighter particle. It is moving with a velocity U2. So what about center of mass? And both are moving with equal speeds. Okay, problem has become a little bit easier, that one. So what is the velocity of center of mass, what direction? Because M1 greater than M2, I'm assuming. This is heavier. A lot of background we are setting up this one, heavier. This is a lighter particle. So then what is the expression for velocity of center of mass? This is all before collision. Huh? Before collision. Okay, now what is the expression for velocity of center of mass? This should be equal to m1u minus m2u I cap by m1 plus m2. Keep it this, it's a very important equation which is going to help us a lot. And then in C frame, how the things will be for us? In C frame, the same problem. In C frame, for that I need what is the velocity of the one with respect to center of mass, that one u1c is needed. No? So what is u1c? Velocity of one with respect to 2. What is velocity of one? U, u I cap, m1u plus m2u I cap by m1 plus m2. Solving this, we'll get, I'll get this as 2m2u I cap by m1 plus m2. Similarly, you can find out u2c also. I'll directly write it. Similarly, velocity of second particle with respect to center of mass. Velocity of second particle minus velocity of center of mass. Solving again, what is u2 minus u? So let me write directly here. 2m1u I cap by m1 plus m2. Okay, now go back to momentum with respect to center of mass is always conserved, no? This is before collision. We are discussing everything, this idea before collision. So now in C frame, how do it will appear? I think I'll write it that C frame here only. No. Now in C frame, how do they appear? Look at this U1C. U1C is towards right, no? Positive. Whatever is U2C towards left. So in the C frame, the same particle is that okay? No. So U2 I substituted all with sign, no? Everything. So I'll end up. So this is where in C frame they appear moving. So with a speed u1c and u2c, that. And now what is the momentum with respect to center of mass? Here we'll calculate momentum. This is all before collision. What we are discussing is before collision it is. Now momentum with respect to center of mass is always 0, no? So this one, so let me write m1 u1c minus this one. So momentum with respect to center of mass. momentum with respect to center of mass before collision it is. So this should be equal to how much? M1 U1C bar plus M2 U2C bar. Anybody, how much it should be? It must be 0, no? Check it once. Substitute here M1, 2 M1 M2 U I cap M1 plus M2 minus 2 M2 U1. So it will be 0. So momentum with respect to center of mass will always be 0. Now from this, can we conclude anything? M1 U1C should be equal to M2 U2C. I got equal to 0. So finally, so what I can equate is M1 U1C is equal to M2 U2C. This is from this equation, I'm concluding this much here. So this is called equation A. Equation A got on. No? So let me take this as B. This as equation C. So one very important M1 U1C equal to M2 U2C. I'll let me call. I'm giving number so that it'll be very easy because little bit almost 10 equations is what I have to generate. No, let's proceed like this here. Momentum with respect to center of mass is always 0. There's a comment, I'll write it nearby. So it'll be easy for you. This is before collision. Okay, now let's come for after collision, what will happen? After collision, okay, let's get into the problem. After collision, the heavier particle is observed to deviate from its original direction of motion by an angle 30 degree in the laboratory frame, and in the C frame, it will get deviated by 60 degrees. So let's put both the diagrams here. No. What do you mean by that? Original direction, how the particle 1 was moving towards right. No? After collision, it will get deviated by an angle how much it is? Saying 30 degrees. So this will be 30 degrees. This will deviate by 60 degrees. So this is the particle M1. In ground frame after collision, it will have speed V1. In the laboratory frame after collision, it will have V1C. So this is what that beta and this is what that alpha. Originally how it was moving along axis. This is very important, the first diagram. Now what do you expect the other particle? The other particle? No, this is the we are not bothered that angle. Leave it that is some angle theta. Okay, now this is what? Lab frame. This is C frame. Now you have to ask very good question to teachers. So why you are here? This okay? They'll collide and they'll get deviated. What about here? How come? Why they should be equal and opposite? Because momentum with respect to center of mass must always be 0, no? Because in C frame is what this diagram is there. If this deviates, if it is moving along this direction, then the other particle should have momentum opposite to the first particle in C frame. In the ground frame, momentum is conserved. First of all, you can ask questions like, okay, what makes them to deviate? There's a collision of particles, not like a balls. Here is saying balls, then here is saying particle. So what we are discussing, it's a particle only. Don't get It should be particle only. The wave particle is observed deviated from its original direction. Sir, why you are not writing quotient of restitution? For subatomic particles, quotient of restitution is not defined. Any reason for that? Electron, can it undergo deformation? Nuclei, can it undergo deformation after collision? I think it's quite meaningless, no? So therefore, the quotient of restitution is not defined for subatomic particles. Then, sir, for subatomic particles, what I should do? You can apply if the elastic collision, conservation of kinetic energy. If the inelastic collision, then kf will be greater than ki, kf will be less than ki. That's another thing. Next after this, so what happens? Momentum in any direction you can conserve, because like it's like a 2D collision, no? In any direction, usually we prefer along x, along y, or in any direction it can be conserved here. So when collision of subatomic particles come, the momentum conservation is what going to help us. And quotient of restitution is not defined, because say, what do you mean by deformation? Deformation, the body should undergo deformation or reformation, no? Is it possible for electron to undergo deformation? It's a particle, no? No further deformation. Similarly with nuclei, no deformation. Got it, no? So no way anything you are going to bring E into the picture. This should be very clear. Okay, let's do one thing. After looking at the diagram in the laboratory frame, what is the velocity of center of mass? Of course, they move in some different direction here, no? M1, V1 bar. This is after collision, no? Lab frame. After collision. This is C frame. After collision. Now, what is the expression for velocity of center of mass here? Vc bar should be equal to M1 V1 bar, M2 V2 bar by M1 plus M2. Do we know V1 bar? We don't know. Do we know V2 bar? We don't know. But we know due to collision, what will happen to velocity of center of mass? Should remain constant, no? The velocity of center of mass will not change. Will I agree? Go back, because what is the net force acting on system during collision will be 0. So velocity of center of mass will not change. So shall I write Vc bar is in fact equal to Uc bar from equation A? Velocity of center of mass should not change. Means even after collision, how velocity of center of mass here will be moving. For your understanding purpose, I'm just putting it here. It will continue to move like this. This is a very important part of the observation what you are making. Keep it this. Okay, that one. Now in C frame, we'll see that one. Momentum with respect to center of mass will be 0 before collision. After collision also, I just put a one very broad statement, no? Momentum with respect to center of mass is always 0, either before collision or after collision. Here is, let me write, is center of mass. This is before collision. After collision also, will it be 0? Yes, it should be no, because momentum with respect to momentum of system with the center, it should be always 0, that one. So the same idea, I'm going to bring it here, no? Momentum before collision also. What is the basic idea? Momentum with the center of mass is always 0, that one. So from here, PCF, I'll write it. Momentum of system with respect to center of mass, finally after collision. So what is the formula? M1 V1C So if I equate, it will be like this. M2 V2C. M1 V1C by M2 equal to V2C. This is equation 1. I'll call this is equation 2. This is equation 3. I think almost now we are able to complete the problem. This the background is what we needed here now. Okay, fine. 1, 2, 3, which I'm going to take help of. These are ABCs. These are about initial thing, that one. This is the after collision. This is the before collision. So fine, okay. What is our, how many times is asking? Just m1 by m2, no? Are you able to see, all of you? There's a data, there's a information, what is given in the question, we have put it in an order. Okay, let's come for how to get m1 by m2. Shall I take help of equation 1? We don't know u1c and u2c, am I right? If I look at the equation 2, we don't know v1c and v2c. First of all, the u itself we have assumed, no? So something we have to work out further. Let's take the vector diagram. Can I write v1c is equal to v1 bar minus vc bar? How the center of mass, here it's in a C frame. After collision, velocity of center of mass will be moving. So shall we bring v1, vc and v1c? Some very good information available here. Some vector relationship will take it, because what is v1c bar, you can write v1 bar minus vc bar. So draw the one vector diagram. Let's see what will get it. I'll scroll down this one. So looking at after collision, the information. Next part of the problem. I will draw the diagram like this. Can I combine? This was the initial V1C. You see V1C, how much of angle V1C? It is making angle beta equal to 60 degrees. What about V1? V1 was making an angle 30 degrees here. So shall we combine these three vectors, and we know velocity of center of mass, how the vector diagram will be. Try this one. This is very important part of the problem. So it will come like this, no? If I draw the vector, this is V1C bar, this is V1 bar, and this is the velocity of center of mass. So then from mathematics, what we know, V1C bar should be equal to V1 bar minus VC bar, no? So let V1 bar, what we can write, V1C bar plus VC bar equal to V1 bar. Now, what is the resultant? The resultant of VC and V1C is what? V1. And what is the angle it is making? It is making an angle alpha here. So tan alpha, go back to the vectors. So what is tan alpha? V1 will be resultant of VC and V1C. We know velocity of center of mass. So V1C, yes, I'll try to see what will get it. So tan alpha, what I can write it at? V1C sine beta cos beta. So now we know beta alpha. So some had to search for, and we know VC could UC. V1C is what? I had to search particular equations. Tell me what I should do after this. This is about the everything about the problem. V1C and VC. If I can get some, I should bring M1, M2 here in this equation, because I know alpha, beta, I can manage further the problem. So let's do one thing. Let's go back to as collision. What is the nature of collision? Collision is elastic, no? As collision is elastic in nature. What will happen to total kinetic energy? Will be conserved. In center of mass frame also, they must have. So in C frame, what is the equation I can write? M1 U1 C square plus M2 U2 C square. This should be equal to M1 V1 C square plus M2 V2 C square by 2. As collision is elastic in nature, so in any frame, kinetic energy will remain constant or will be conserved. So M1 U1 C square plus M2 U2 C square, this one. So now let's me, so what are the equations? 1, 2, 3. Let me call this equation 4. Now what we are trying to do, V1, VC, some relationship is what I'm trying to obtain here. VC, I can write it as UC. A little bit symbols. We'll keep this much in hand. Yeah. Now, shall I take help of equation 1, 2? Substitute 1, 2 in equation 4 because we have V2C, we have U2C. So that I'll get only U1C and V1C. Then I'll get relation between U1C and V1C. Then we'll see that what I can do further. So put 192 in 4. M1, M2. U2C I can write it as M1 U1C by M2 whole square. Try to see equation 1 I'm keeping here at this place. Then M12. Don't now replace V2C. What is V2C from this equation 2? So I think what we can do here. Shall I write directly? U1C is equal to V1C. Look at all of you. Look at the terms M1, V1C here, M1, M2. So let me take this equation, very important, equation 5. Okay, somehow I brought V1C here. V1C is what I'm able to express U1C. We don't know U1C. What to do with U1C? Just slide up. Do we have U1C? 2M2 U by M1 plus M2. Do we know VC? VC is what? UC, no? And do we know UC? Equation A. I'll write down all things. So V1C I'll substitute here. So this is the equation. I'll call 6. So such a lengthy problem can be asked in advance because I'm explaining in detail. You can solve it in very half an hour. You can, like in exams around 6 minutes, you can solve it. No, let me substitute 5 in 6. Tan alpha U1C sin beta VC plus V1C now we know U1C and we know VC is equal to UC, that one. So 5, 3 and 5. Let me write here. So in place of VC, what I can write it as? UC. Do we know U1C and UC? Equations A and B. Magnitude substitute. M1, U1, M2, U2. Magnitudes you substitute. So putting A and B in equation 6. I think problem is over. Let's substitute here. So tan alpha U1C. I know value already. I did know 2M2 U by M1 plus M2 sin beta. What about velocity of center of mass? Velocity of center of mass will be M1U minus M2U by M1 plus M2. Again, this is 2M2U by M1 plus M2 cos beta. I think M1, M2 all will get, so that this U will get eliminated. We don't know U, we assumed it. Then only in terms of M1, M2 and M1 plus M2 also will get eliminated. So the final equation here will be, okay, now it's only solving, almost we have reached it here. 2M2 U sine beta M2U plus 2M2U cos beta. This is tan alpha. You also remove it. So take M2 common. Take M2 common. If you take the M2 common, so this will be tan alpha equal to 2 sine beta M1 by M2 minus 1 plus 2 cos beta. We know alpha beta will get the ratio M1 by M2, which will be 3. Just very simple only. This is very important idea. This is the important idea. If you can get this diagram only, you can manage. Otherwise, not possible. Rest all everything we know. They are the basic things. This drawing vector triangle is what? Everything here. The particles, subatomic particles, they collide and they get deflected in that way. This is the nature of collision of subatomic particles, not